Hello and welcome to yet another video about Pickles. In this video I will show you the inner workings of Pickles, and I will do that by walking you through the path the code takes while executing Pickles. So I'm gonna use the command line runner as our vehicle of choice here. I think I already showed part of this code during one of the other videos. But anyway, if this one is the one where you start watching the videos, this project is a classical Windows command line interface. So it has a class called program and has a private static method called main with a string array for arguments. That's our entry point, classic .NET stuff so far. I use AutoFac for a dependency injection system. So I'm doing a lot of AutoFac magic in here. Then I resolve the configuration. That's the part where we tell Pickles use this input directory, use this output directory, these options, la-di-da. So, my apologies, my cat Tiger is clamoring for attention again. Yeah, so we resolve the configuration and we parse the configuration. And if everything is in alright, so if the configuration says this is a valid configuration, we should continue. Then we do the actual running. We resolve a runner class from the AutoFac container and run the program. And if, well, there's a bit of locking, exception handling, and so on. Nothing spectacular here. So, I'll walk you now through some of the classes and interfaces that are useful here. First, the iConfiguration interface. It's really a basic thing with a feature folder, output folder, so documentation format, all the options. One of the more interesting methods is, or properties, is the test results files. Which is a sequence of file info base classes. And you can add result test files, you can add multiple test result files, enable or disable the experimental features, and a few other things. The file info base class, that's just a standard .NET file info base class. Right. The command line argument, the command line argument parser is this one. So we are using the library ndesk options to parse command line arguments. This is a very old library if you're thinking about migrating Pickles to .NET Core. This is probably one of the things you will need to replace completely, which will very probably break the command line arguments, because there's no guarantee that a different command line argument library will provide the same way of declaring parameters. Okay, so we pass the command line arguments. We set the current the feature folder and the output folder to the current directory by default. Incidentally, this file system interface here is iFilesystem. That's from the System IO Abstractions library. So I'm not using directly the .NET classes for file system access. I use Systems IO Abstractions package for that, so I can mock out the file system for unit tests. Okay. Somehow came back to a different class. Let's expand the file. Right. So we use the current directory to say the feature file and the the feature folder and the output folder. So if we don't specify any folders, then it's just the current folder. Good. We pass the arguments. And yeah, if we just want to display the version of Pickles, then we do that, and we return if with false, because we should not continue. If help was requested, then we display the help and return false. And then from here on, we sort of assume that yeah, we really want to convert feature files into a living documentation. So we get the feature directory, if it was defined, the output directory, the test results format, which is an enumeration that we pass. So we have NUnit, XUnit 1. Okay, there's an interesting mistake in the documentation here. MS test and so on. All the formats that we support. Then we take on board all the files with test results. And the thing is, you can provide multiple files with test results. If you spread the execution of your feature files over multiple runs, then you can still incorporate those different results into one living documentation. So we get all those test results. We dig through the semicolons to separate the different files. We expand wildcards. So there's quite some flexibility in specifying the test result files. So we take that on board. More parameters, nothing spectacular. The documentation format. So we have HTML, Word, JSON, Excel, DHTML, Cucumber, Markdown. Incidentally, you can use this this enumeration as a history to see which output formats were created first in Pickles. It started off with an HTML version, then a Word version, JSON, Excel was added, the dynamic HTML, then came Cucumber, and the last one to be added was a Markdown. Yeah, more parsing of comments is not very, there's no rocket science in there anymore. Yeah, so that's how we go through the command line arguments. And once all of that is set up, assuming we should continue, so assuming we really want to pickle some feature files, we then get the runner and run. So the runner. This is like a director class that calls all the subcomponents and ties everything together. So this is this class has the main method run, which retrieves the configuration and then verifies whether the output folder actually exists and creates it if it doesn't. Then we retrieve a directory tree crawler. That's the class that goes through the directory where the feature files are and gets us all the files that are of interest. And there's also a parsing report involved, which is not so spectacular. That's just a list of strings with messages. Okay. Oh, come on, I keep forgetting to keep open this file. Yeah, so the directory tree crawler goes through all the files. If there's any message at all from parsing, then we log that as an error. If there were no feature found, that's a warning and we stop processing. Then there's this little method apply test results to features. There's a whole lot hiding behind that. Well, I'll come to that. And then we resolve the actual documentation builder. So in the configuration, we specified which output format we wanted to have. Each of those output formats implements this iDocumentation builder interface, and you just tell the interface build the documentation for these features. Yeah, and that's funny because yeah, because I was thinking parsing report any is checked twice. Now, on the first time we check it, log it as an error, but we do continue processing. So we generate the documentation even if one or more of the feature files cannot be parsed, but we throw an exception at the end. Good. Let's look into the directory tree crawler, then apply test results to features, and then into the documentation builder. The directory tree crawler, yeah, so has a crawl method, and okay, let me briefly go through the file. Yeah, so it collects files, it collects directories. Basically, it recursively crawls through directories and files. If there's files to be found, so a directory can contain multiple files, and we detect which of the files are actually of interest to us. And for each of those files we find, we create a node to add to our list of nodes. So you can visualize this. Picture a directory structure with directories and files, and from that we derive a list of from this directory structure we derive a similar structure that contains feature files. So we have a method for ordering the file nodes. This is basically we order them by name, nothing spectacular. How do we know which of the files in the directory structure to convert into the list of nodes? There we have a relevant file detector. Good. Yeah, so feature files are included. Markdown files or even plain text files are included. However, there's one text file we do not want to have. That's the chbrush file list absolute txt. And if it's an image file, we also take it. There's an image file detector which says anything that's PNG, JPEG, BMP, or GIF is an image. So, yeah. Yeah. So our directory tree crawler crawls through all the files and directories below its starting point. For each file in there, it determines, is this file relevant to us, which may be a feature file, a text file, markdown file, or an image file. And if it is relevant, we take it into our list. Good. The feature node factory, that creates inode implementations, and there are well, whether this is an, it depends on whether it's an oh, wait a moment. Yeah. Yeah, it depends on whether this is a feature file, a markdown file, an image file. For these three types, we return slightly different inode implementations. Good. So that's what the directory tree crawler does. Good. So at this point, we know which feature files we have and which feature files will eventually be turned into a living documentation by the documentation builder. But first, we're going to go through all our feature files that we collected. We're going through every scenario in each of those feature files and look up the test results for those scenarios. That's what apply test results to features does. Yeah, this looks like a small method because most of the magic is happening in the background. We have some test results in somewhere in our configuration. Remember, we provide the paths to one or more test result files. Those are parsed. And test results, if you give this interface a feature, it will tell you the result of the feature. Remember, the result of the feature is the aggregated result of all the scenarios in the features. If they're all pass, then the feature passes. If there's at least one ignored, then the feature is ignored or inconclusive. If there's at least one failed, then the feature fails. And there are similar results methods to get the result of a single scenario, outline of a single scenario. Well, hold on. There are methods for getting the result of a scenario outline. Skip one. There's a method to get the result for a single example within a scenario outline, and also the method for getting the result of one scenario. There are implementations of this interface for each test result format that we can read. So there's one for NUnit 2, NUnit 3, XUnit 1, XUnit 2, SpecRun, MSTest, and so on and so on. Good, so we have our test results, and then we iterate through all the feature nodes in the tree. We guard against null here. If the configuration has test results, then we set the results, otherwise we set the result to not provided. I was just briefly thinking this check for configuration has test results could be done outside of the loop, but yeah, we probably still need it in here because we're setting some property value on the item that's being looped. So, but assuming there are test results, then we set the result at feature level, and then we set the result for individual scenarios under the feature. This is basically a method that has only one line in the implementation in order to better express the intent of the method. So that's something you will notice often in Pickles. I have a lot of small methods that have maybe one or two lines, but I extract them into many methods anyway in order to express the intention. So my intention is to set the result at feature level, and it just happens that the statement for that is this. Good. Setting the results for individual scenarios under the feature is a bit more involved. we loop through all the feature elements of a feature. So a feature is the Gherkin feature file, and it has several elements like a scenario outline. Also, the background is a feature element. So we're looping through the feature elements, and we first check whether it's a scenario. If it's a scenario, we use our test results interface to get the results for that scenario and set it. If, on the other hand, the feature element is a scenario outline, then we go through all the examples in the scenario outline and set the results for each example. And then the result of the scenario outline by itself is the aggregation of all the results for each example. This aggregation or merge is done in a little extension method where it says, if there are no test results, then the result is inconclusive. If there's only one test result, it's that test result. And then there's an interesting thing here. Most unit test runners that I know treat a class of tests as inconclusive if there's at least one inconclusive test. Some other runners will still list the class as passed, even if there are inconclusives, as long as there is no failed. If we say passed is more important than inconclusive, then we say it's passed if there's at least one passed, and else if we say inconclusive is more important, then it's inconclusive as soon as there's one inconclusive. Good. Oh yes, and if any of you were wondering what about failed tests, well, actually, as soon as there's one failed test in the set, then the entire thing is failed, of course. Okay, so the runner has now applied the test results to the features. So summarizing again, first we crawl through all the files in the directory and the subdirectories, and we retrieve the relevant files. Then we and in that process those files are converted into nodes, and those nodes can be feature nodes, markdown nodes, image nodes. We have our list of features, and now we apply the test results to them. We do that by going through all the features and by taking specifically the feature nodes. There's no sense in applying a test result to a markdown file or to an image file. So we go through all the feature nodes. There we set the result of the entire feature, and we set the result of the individual scenarios and scenario outlines. Good. How we determine whether a test result is pass, failed, inconclusive, that is up to each individual implementation of the test result interface. We'll get to that later. We will look at one of those implementations as an example. Good. And now we can start building the documentation. So for that we retrieve an iDocumentation builder, and we build the documentation. iDocumentation builder is a very simple interface. It only has the build method. So we call that, and sorry, there's Sammy, the other one of my cats. Yeah, I know. Sit down and be quiet. look up one of the implementations of this method. I personally like the HTML implementation. It's one of the earliest, it's one that I know best. Good. There's there's a bit of logging. We write some resources. So the website the website that is the result of the HTML documentation builder contains some CSS files. It contains a few images to say passed, failed, inconclusive. It even contains some fonts and some scripts. And those resource files are written to the output file as the first step. And then we go through all the features and visit the nodes. So we have our tree structure of features. Feature is in this case perhaps a bit of a misnomer, because in the tree we can also have images or markdown files, but we go through them one by one. Right. First of all, if the node is in fact the index markdown node, like a file called index.md, that can serve as a description for the root of your tree level, then we don't do anything. Good. And then we retrieve the path. We determine, is this actually some content, or is this a structure? So if it's a structure node, then we create a new directory to put it in there. Yeah, if it's content, then we write it. Then we will create an actual HTML file with the content of our feature file. Yeah, and here in write content node, we take our node, which is a feature file, we put it through the HTML document formatter. That creates an XML document, and we save that to the disk. So the HTML documentation builder is a class that does some housekeeping on a file system level. The actual formatting of the living documentation is done by the HTML document formatter. We'll go visit that one. Good. Let's take a look at the Solution Explorer now. Here we'll see a lot of formatters. So the HTML document formatter works like this, that it delegates formatting to subformatters. So for a markdown file is formatted by the markdown formatter. There's one for images, there's one for the header of the document of the web page, is one for the footer of the documentation. So well, I suppose this is a well-known pattern. Good. So the main method is the format method, which uses a header formatter, the table of contents formatter, the HTML content formatter, the HTML footer formatter. So those are all parts of the web page. So we are building a web page here, an HTML document, which is mostly an XML document. We make a body, then the head contains a title where we add the name of the feature. We link a style sheet. Remember, the HTML resource writer wrote some style sheets to the disk. They're included here. The head gets some JavaScript. Yeah. So a lot of formatting documents. If we go to the feature formatter, that's implementation. Oh no, that's there's. That also has a format method where we create a div, an h1 with the name of the feature. If there's a background, we use a scenario formatter to add the background. For all the other feature elements, if it's a scenario, we use an HTML scenario formatter. If it's a scenario outline, we use the HTML scenario outline formatter. I'm not going to review every single formatter with me. That would be a very boring video. But the gist of the thing is that every one of those formatters creates an HTML fragment, and they are puzzled together to form the entire page. Good. So that's how the documentation builder works. And at that point, we have our entire living documentation. Step 1, we collect all the files, and we convert that into our own node structure. Then we apply all the results to the features and scenarios and outlines, and then we render the documentation. I showed you the HTML documentation builder as an example. Most of the other documentation builders work similarly. What I did not show you yet, and what I will do now, is an implementation of the iTest results interface. So for that, I'm going into the test frameworks directory, and because I have been talking a lot about NUnit so far, let's continue that. Okay, so I'm going to now show you one of the implementations of iTest results. It so happens that even though every unit test runner has its own implementation of this iTest results interface, there is still some code that is general, that is common to all of them, to all of the implementations, and that's put in here. For example, determining some aggregate results, like how many inconclusives are there, how many passed, how many failed. Good. And then okay, NUnit, because I support two NUnit formats. NUnit has a class deriving from single test result base, where it provides an implementation of the getFeature results method. We retrieve the feature element. If we can't find it, then we say the result is inconclusive. If we can find it, then we look into the file and select the results. So in order to really fully grasp this code, it's good to have an example of a NUnit result file with you. And there you will find that we just dig through the XML and find the correct node. I can briefly show you one of those XML files. So test case is basically the element that wraps each scenario in the NUnit result file. So for that reason, we start looking for test case elements. So I advise you to, if you want to understand this code in detail, I advise you to keep the result file open in one window and next to it the code, so you can walk through it and see how we select all the items. Yeah. And then here are the things that are particular to NUnit 3. Again, there's also test suite, some XML, querying through XML, retrieving the scenario element with test case and property scenario outline, which is called test suite in NUnit. Test suite contains a test case. So this is really all very nuts and bolts for this particular test result provider. Good. We have other implementations of iTest results for the other test result formats. I'm not going to dig through all of them with you because it's all they all operate according to the same principle. We need to retrieve the result of a feature, then we go dig into the result file, and it depends on the format of the result file how we go digging. Yeah, that's basically in a 35-minute nutshell how Pickles work. I hope you find this useful. You can hope you could follow through, experiment with the code, and ask questions if you need more details. Thank you.